Hello, hello everyone. I'm gonna go ahead and get started now. And actually I wanted to start with a show of hands here. So how many people develop in React on a day-to-day? Fantastic, most people in here. Okay, how many of you all use Next.js already? Okay, so about 50-50, this is gonna be good. So I'll be able to share with those who are already using it. You'll get something out of it, and then for those of you who aren't using it yet, hopefully you'll learn some new things, all right? So I've been using Next.js for several years right now, and I just really got into understanding like how it worked in and out, right? So I'm kind of sharing things that I learned about how we can render different ways with Next.js. So I just wanted to let you know that here's a link to a QR code to the slides in advance. I'm gonna have lots of links and stuff like that, so feel free to scan that. I also have a link at the bottom if you wanna type that in, a little short-ish link there that you can follow. And if you go to my website, benmvp.com, you'll also see a link to the slides there, all right? So you're covered in many different ways in order to get the slides. So when React jumped on the scene in around 2015 or so, it became a game changer for a number of reasons, but the first one was that other UI libraries that existed at the time, in order to mutate the state or store state, it was all done in the DOM. So you needed to have a browser context in order to render anything. Right, so think of jQuery or Backbone, all of those types of libraries. But what made React new and special at the time was that it separated the rendering of the UI with actually flushing it to the DOM, right? So what that enabled is that now the language, let's say, or the library could be separated from the rendering. So React Native works because you can use React for the UI and then render it or flush it to a mobile native environment. Or Netflix and other TV providers, streaming providers, also use React, but they have their own proprietary renderers for the TV platforms. So what we have here is probably the most popular renderer, obviously, rendering into the DOM here. So you render the UI, have it all in your app, and then finally you create the root and you flush it down there. So what Next.js did in the very beginning is that it leveraged one of React's other renderers, which is the ability to render to a string, right? So this began the whole isomorphic React revolution, if you ever heard of that, where we would basically be able to use the same UI to render on the server initially as we used on the browser after it hydrated. So Next.js started around, I want to say 2016 or so, shortly after React launched, and it was created by Vercel's founder, Guillermo. If you've heard of Guillermo or Vercel, it was named Zeet at the time and then got rebranded. But the simplified version is what I described. You render on the UI, render on the server, get out that string, include it in the HTTP response, so it's there in the initial page, and then it gets hydrated. React hydrates it on the client, adds event listeners and all those sorts of things once it makes it into the browser. So then around 2019, this was like Next version 8 or Next version 9, they started focusing on pre-rendering the app. So before even getting to the server side, pre-rendering at build time, so all of these HTML files were already generated. And then ever since then, Next has been adding various different features, functionality in order to make that even easier and more performant. Okay, so I want to take the rest of our time here to kind of go over those different strategies and how we can apply it into our own apps. But before we begin, can I get everyone to stand up? Everyone to stand up. So, we've had lunch, it's all digesting in there, you're gonna get a little tired. So one thing I like to do in my talks, you don't have to stand up, but I like doing air squats like this, okay? So what we're gonna do, I'm gonna count together. We're gonna do 10 squats together, okay? And if you don't wanna do it or you just wanna use your arms, that's totally fine, all right? So here we go, ready? 1, yeah, 2, 3, didn't think you were gonna do this, huh? 4, here we go, 5, halfway, 6, 7, yep, I'm getting tired. 8, we're almost there. 9 and 10, nicely done, nicely done. Okay, I could totally tell who really works out. You know, they were doing like the real squats and everything, but yeah, so let me formally introduce myself. My name is Ilegbodu. I'm a Christian, a husband, and a father. So here's my family here. My wife, Rashida, we've been married for 13 years. We celebrated last month in September, number 13. And we have, oh, well, thanks. I got some claps in the front. I'll take those claps. We have 3 kids. Our oldest daughter, Simone, she is 9 years old. Our middle daughter, Avery, she just turned 7 last month as well. Then our youngest son, Asher, who never likes smiling for pictures, he is 4, soon to be 5, there. All right, so I'm a Google developer expert in web technologies. I always talk about web technologies, and I'm currently a front-end architect at Stitch Fix. So if you've never heard of Stitch Fix, it's an online clothing platform where we combine technology and stylists and AI to figure out what clothes would best fit you. And we put it all together in a box, 5 items, and we'll send it to you at whatever cadence that you want. So enough about me, where I work and such. Let's look at this product page here. And it's actually the product page on Vercel's demo site that they use. All right, so it's an e-commerce page. If you look at it, it's got a title, it's got a price, add to cart button, related products, the image, like all of these different pieces that make up a product page. So I want us to keep all of these things in mind as we start talking about the different rendering strategies that happen with Next.js. Oh, and before I continue, just wanted to point out that Next uses what's called file system-based routing. So wherever you put your page components is the route that it's going to generate. So here we want to have a route at, acmestore.com/product/Acme hoodie. So then you would put the file at source, pages, and then product, and the file name. But since we have a product page that's going to have multiple different pages, you could have Acme hoodie, Acme shirt, whatever the case, Acme shoes. We're using what's called dynamic path-based routing. So that's why it's in the square brackets there to signify that it's going to be an ID. Multiple types of pages could be there. Okay, so let's talk about client-side routing, or maybe you've heard of it as CSR. It was definitely the most common, I would say, method of rendering React applications. So think of Create React App, right? Everything is done in the browser. So let's say within our component, that route that I talked about, /products bracket ID, the default export is the page component. So it looks like any other React component, really, that you can define, but it's what you export from that page file becomes what's rendered on the URL. So for our product details page, Next will pre-render some minimal HTML at build time. So in this case, it'll just be the loading state, right? Because we won't have any data there. It'll just be a loading spinner. Here I have, loading ... there, but some kind of minimal page. And then from the URL, we'll get that ID I was talking about. So ID from the router will be Acme hoodie in this case. And then we'll use that ID from the query object that we got from useRouter into our API request there. So this is all happening on the browser because it's in a use effect, right? That only executes within the browser. And then finally, after we get the data, we call set data, the set state, then our page will re-render with the new data that we have. So here's the thing, just to call it out, may be obvious, but because the API is being called every time the page loads, for every render, we'll always get the most up-to-date data, right? So we'll have the latest price, the latest title name, for instance, the latest size, availability data, if the product's on sale, et cetera, right? So that means we always have fresh data, which will make sense as we continue talking about other ways to render. And if you remember, there was that related products carousel at the bottom, we'd probably still render that as a separate render so that we're not blocking the whole page render there. So CSR is great for dynamic content. And since most of the page is blank, it actually, the response that comes back is really, really fast. Like it could come from a CDN because it's fully cached there. However, everything is rendered on the browser, so that means that render times can be slow depending on what's being rendered. And because you're making the API request every time, your page render time is going to be at least as slow as the API response, right? And SEO is pretty worse because there's nothing in the page for the crawlers to scrape. Now, there are some that are able to execute JavaScript and really figure out what's going on, but there's no guarantee there. So while client-side routing will work for your product page, and actually lots of product pages or pages in general are client-side rendered, I don't think it's ideal. This rendering strategy is ideal. Instead, CSR is great for highly interactive experiences. So think of something like Figma or Google Docs or charting libraries, those kind of things, or even a page that depends on a third-party widget like PayPal checkout or Stripe checkout or something along those lines, right? That's great, okay? So then, but we'll see though that we can still use client-side rendering and other different rendering strategies to sprinkle on top there. Okay, so let's move on to server-side rendering, or SSR, the second acronym we're gonna learn. So you may have also heard of it as dynamic rendering as well. So let's jump right in. The way to render on the server is by exporting this function called get server-side props. And just like that, you're server-side rendering, just by adding that function. So you don't have to necessarily put the file anywhere else or do anything crazy. You just add that function there. So for our product details page, we move the API request from the client and use effect now into the get server-side props. So that ID, remember the dynamic path bracket ID, now instead of getting it from use router, we get it from the params context that's passed to get server-side props. Then the props data is returned from get server-side props. And that ends up becoming the props to our component. So we get the data from the server, it gets passed as props as a data object, or really whatever we want to call it. And then now that's what we use in our component. And then the server will render the page as however the UI we want, but it's as HTML now, so just vanilla HTML there. So similar to client-side rendering, server-side rendering, we're making the API call every time. So the client's gonna hit our page, we're gonna hit the server, we're gonna call the API, get the latest data, and then render it to the page. So just like that, we always have the up-to-date price, out of stock of sizes, et cetera there. So the thing about server-side rendering to remember is that this happens for every request. So we could also make the call to get the related products API here and get server-side props so that when the page comes out, it has all of that data too, but that's probably gonna be slow. So we'd probably wanna do that still on the client. So SSR is really good for dynamic content, just like CSR, or client-side rendering, because like I said, we're getting the data on every request. And it's also really good for SEO because the data will be in the page that's coming back from the server. And as a result of that, browser rendering times are really fast because all the HTML is there. It doesn't have to grab it from an API and then render in the browser. But that all comes at a cost, and that cost is slow response times, right? Because now the server is having to do all of this rendering. So the server is probably fast, right? Faster than the browser, but it's still going to take time to make that API call, get it back, render to the HTML. So let's go back to our PDP, right? Our product details page. If the data was constantly changing, like every time you render the page, you may get something different, then server-side rendering may be a good fit. But if the data is mostly static and everyone's kind of seeing the same UI, then server-side rendering will probably be overkill and not the best solution. So SSR is like the OG way of rendering, I would say. Like everything used to be server-side rendered. If you think about your PHPs, your Perl with CGI bin, for those of you who used to code way back in the day, all of those kind of experiences were all server-side rendered. But server-side rendering is good for pages that have data that change all the time or is really user-specific. So if you are gonna get a product details page that looks very different than the one I'm gonna get, then server-side rendering is really good. So if you think of personalized search results or a checkout flow, those sorts of things, good for those. Okay, so we talked about client-side rendering, we talked about server-side rendering. Let's talk about static site generation, or SSG, our third acronym. So around 2019, this company called Gatsby, that you may have heard, really popularized static site generation in the JavaScript community. Jekyll, if you've heard of that, a Ruby-based tool, existed 5 or 6 years before that as a static site generator. But in the JavaScript ecosystem, Gatsby rendered all pages by default. So here's how SSG is different than SSR, besides being one letter different. HTML pages are pre-rendered at build time. So this is even before the server starts. So I like to think of it like the mental model is that it's being generated at CI time. So like in your Travis CI, Circle CI, GitHub Actions. It's probably rendered on the server right before the server runs. So it's right there in the container. But that's the way I kind of think of it, is that it's happening way before the server runs. So what that means is that the same HTML is being used and returned for every request for every user. They're all getting the same content there. So the way to do our dynamic page here, because we're gonna be getting different HTML pages for different product details pages, is to first export this function called getStaticPaths. And its goal is to basically tell Next, well, what are all the pages I need to generate? So there'll be Acme hoodie.html, Acme shirt, Acme shoes, like all of these different HTML pages that need to be pre-rendered before the server starts. So in this case, we probably call a different API, right? an endpoint that will give us all of the products there. And then we will kind of map and massage all of this to effectively get an array of paths there. So if our site has 100 products, then get static paths will return 100 paths that we want to render. So FYI, the params object here that we are returning, there in that object, it has ID as the property. That ID has to match the name of the file. Bracket ID.tsx matches the params ID. So I did want to call out this fallback false. It's a key user experience, I guess, that's important. So what it means is that if someone goes to the page and they go to /product/Ben's shirt, let's say, if that wasn't in the list of the 100 products, then I would get a 404 page because it's saying that only the pages that were pre-rendered are allowed to be visible. But alternatively, we could do fallback is true. And what that means is that we will still pre-render those 100, but then if anybody comes to the 100th or some other URL, we'll actually try to render it. So we'll make the request to the API to get the data and show a loading state until we're able to render it there. So this is really helpful if your site has thousands or 10,000s of pages. Maybe you have thousands of blog posts, those sorts of things. So you pre-render the most popular ones and then leave the long tail for those to be rendered on demand. And then when they're rendered on demand, then they're stored on the file system, and then every other time it's cached. Everybody gets the same page. So now, next is pre-rendering at build time, right? So it'll take that ID that we returned from getStaticPaths, and it'll call getStaticProps for every one of those paths. So over and over for every single page so that we can render out every single page. So this is now where the product page component makes the API call. So it's similar to get server-side props in that we're making the API call on the server, not in use effect. But again, it's happening before the server even runs in order to generate an HTML file that'll be saved on the file system. So just like with get server-side props, get static props returns back whatever props we want to use to render. So we get that data, return it as props, and then right there. And then lastly, the page will be rendered, however we want to render it based upon our UI. So the thing to remember is that this is the same HTML that everyone's going to get, right? So there's no differences between those pages. So the appeal of that is that it's super fast. So because there's only one version of Acme Hoodie, that can now be cached on the CDN all over the place so that everybody can get a really, really fast response there. So it's highly cacheable. The downside of that, though, is that there are slower build times. So if I had 1,000 product pages and I tried to build 1,000 pages, that'll take some time, right? However, another positive is that it's SEO friendly. So all of the markup is already there when we return the page. So if we're talking about SEO or SMO, those types of things, all the data is there. So the problem, we're going pros and cons again, the problem is dynamic content. So if everybody's getting the same page, for every request, it's really hard to display dynamic content, right? If my page needs to look different than your page, but there's only one that's cached, that's tricky. So usually in those situations, you have a shell page that is highly cached, and then you would make some additional API requests for whatever is user specific. So then now you have this kind of hybrid static site or statically rendered page and client-side rendered page together in order to have the best performance, but it takes some work in order to accomplish that there. So if we wanted to use, let's go back to our product page, right? So if we wanted to use static site generation for it, we can render everything at build time. So we'll render the title, the price at a given time, the sizes, the add to cart button, all of those things. And then when the page renders on the client, we can make a request to get updated information. So let me find out what all the sizes that are still available and gray out all the other ones. And let me update the add to cart button based upon those selections. Or let me get the latest price because something's on sale. Like those sorts of things. So that's kind of that hybrid model so that the response is fast, but then we want the UI to be up to date there. Okay, let's talk about the last one, because we talked about client-side rendering, server-side rendering, static site generation, and now incremental static regeneration, or ISR. It sounds like super complicated, but it actually is very straightforward when you actually take each one of the words apart, which I'll talk about in a second. So it basically is going to take static site generation and bring the server back into the party. So let's look at that. So everything is very similar to static site generation. Really, the only difference is this one line right here, which is revalidate. And you pass it some cache time in seconds. So what that means is that we're going to pre-render the page, just like before. The only difference is now, once this cache time has expired, the next time somebody makes a request, we will regenerate a new page. So it happens incrementally because it's on the next request there. So that page will get regenerated in the background and then served as stored on the file system again, and then that's the page that everyone will get after that there. So it's basically a way to change the content after a given number of time, after a certain amount of time, without having to trigger a rebuild with like a webhook or something along those lines there. So we can combine revalidate with the third option for fallback, which is blocking. And effectively what that means is that before, without blocking, fallback blocking, when we make the ISR request, the user will get a loading state until they get back the new content. Well, now with blocking, it's going to really seem like a server-side request. So nothing will happen until the page is regenerated, stored on the file system, and then sent back to the user. So it feels a lot like server-side rendering from a user experience, but then the content's going to be cached for everybody else who makes the request. So Vercel, the Next team, called this dynamic at the speed of static. That was like their whole pitch around it. So it's a form of having a hybrid page, basically. So just like with everything else, ISR has advantages and disadvantages, basically. So it really has all the advantages of static site generation, right? The page is pre-rendered, it has great SEO, it returns fast and is cacheable. The advantage or the difference is that it can be updated without a rebuild, which is nice. So maybe we want this product details page, we want the sizes to always be up to date. So, but we're willing for it to be out of date for like a little window, right? Or we're not willing for it to be out of date for a little window. We'll always make a request for the sizes API. But if we're okay with the related products being out of date for a little bit, we can have those regenerated on demand with revalidate. So then if any of the other data, like the image and all that stuff, change in that little window, they'll be updated as two. So ISR is really best for content that changes not immediately or all the time, but will change over time, basically. So I'm thinking of like CMS-like pages. So, you know, your blog, your landing pages, the ones that maybe even your marketing team are updating that you want to have hands-off to engineering. So, you know, they make a change and then 5 minutes later, that change is reflected there. So it's still static. It's not like it's changing all the time. You don't want to inundate the server with all of these requests, but you also don't want it to go stale as well. So here are all the different rendering strategies and I think the best use cases of them. So Next.js isn't just a client-side renderer like Create React App. It isn't just the static site renderer like Gatsby. It's not even just the server-side renderer like how Next used to be, right? It's all of those. And the thing I want to really highlight and for you all to understand is that the whole app doesn't have to be one of those three. Any given page can be any of the 4 different rendering strategies we talked about, right? So I went through the most common 4, I guess I'll say, but there's so many different ways you can weave the different ones together, even on a given page. So if we take a whole e-commerce site and put it together, maybe the login page, your onboarding page, your blog pages, potentially, those are static site generated, right? Because they're the same, everybody's getting it. But then you might use incremental static regeneration, ISR, for product pages or landing pages because they're static, but they could change outside of a build cycle. But then search results, let's say shopping cart, order history, those should be server-side rendered because they're hyper-specific to a given user. And then let's just say your third-party checkout widget, your shipping tracking page that's using some third-party widget, that should be client-side rendered because it's all happening with some script tag there. Okay, actually, before I wrap, you may be wondering, okay, so what about this thing called server components that came out with React 18? Everything I just described was from Next. Next has 2 types of routers now, the pages router and the app router that came with Next 13, the app router. So it leverages React server components in order to accomplish routing. And I elected not to talk about the app router and server-side React server components because honestly, it's really complicated, right? And there's so much nuance to the architecture and how it uses external libraries and how they need to be written and such. So I decided to leave that out. But I do want to highlight, if you're interested, it basically automatically chooses all of these rendering strategies for you based upon how you're making your request for data. So if you're not making any requests for data, then it will give you a static site there. If you have code that's only being used on the server for rendering, then it won't ship that code to the browser because it knows, oh, you're only rendering that on the server. So it really tries to optimize things, especially code size for performance there. But it comes at the cost of more complexity in writing the code. So I've put a link there if you're interested. They have a whole section, Next has a whole section of docs that goes into those details. So I know I just flooded you with a whole bunch of information here. Just wanted you to have time to absorb it. If you have the slides, I have some resources to more content about this, right? So even the methods, get server-side props, get static props and such, and docs about each one of those rendering strategies there. So as I wrap up, for those half of you who had never used Next.js, I would encourage you to give it a try for your next application or push for it at your company. Or if you have used Next.js, the other half of you, I encourage you to go back to your app, look at how you are rendering your pages, and see if they're the most optimal way to render those pages, and make tweaks as you go. So I'll be here for the remainder of the conference. If you have questions about Next or really anything else, feel free to come stop by to chat with me, or you can hit me up on Twitter at BenNVP. Thank you very much. Appreciate it.